Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for confirmation, everyone. So, without ado, let's get started on our discussion on random forest discussion on machine learning itself. So here we are going to talk about classification, what exactly random forest is, and why random forest, introduction to Ensemble method, random forest analogy, and then we are going to discuss on how to exactly to use random forest, and if time allows, then we are going to see a small hands-on as well. So first of all, if we talk about random forest itself, then with the demand for more complex computations, we cannot rely on simplistic algorithms itself. That's a fact. So instead, we must utilize algorithms with higher computational capabilities. And one such algorithm is random forest. So basically, random forest, if we talk about classification, then classification is the method of predicting the cases, the class of a given input data point. And classification problems are common in machine learning and they fall under supervised learning method. Let's say we want to classify our emails into two different groups, spam and non-spam emails. So for this kind of problems where we have to assign an input data point into different classes, we can make use of classification algorithms. So basically, in terms of algorithms itself, we have two different types. We have binary and classification. And if you talk about comparison, like if you talk about comparing classification with versus regression, so classification is simply going to predict the continuous outcome. Like for example, it will be hot or cold tomorrow. And again, basically regression focuses on making predictions on the categorical outcomes here. So basically here we get, okay, what is the temperature going to be tomorrow and so on. So these are going to be defined as a part of regression problem statements. So in terms of types of classification algorithm, so here we have logistic regression, we have decision tree, and then we have random forest, k-nearest neighbors, and then we have naive Bayes. And here we can define in terms of understanding random forest. So basically, random forest algorithm is a supervised classification and regression algorithm. So as the name suggests, this algorithm randomly creates a forest with several trees. So generally, the more the trees in the forest, the more robust the forest looks like. Similarly, in the random forest classifier, the higher the number of trees in the forest, greater is the accuracy of the results. So in simple layman terms, we can say that random forest builds multiple decision trees called as a forest and glues them together to get a more accurate and stable prediction. And the forest it builds is the collection of decision trees, and then it is trained with the bagging method. So before we could discuss random forest in depth, we need to understand how decision trees work. So we can have a common question. So what is the main difference between random forest and decision trees before we discuss on ensemble learning? Let's say we are looking to buy a house, but we are unable to decide which one to buy. So we consulted a few agents and they gave us a list of parameters that you should consider before buying a house. And that may include price of the house, locality, the number of bedrooms, parking space, available facilities. And these parameters are known as the predictor variables, which are used to find the response variables. Now, here's a simple example that can help us understand. For example, we can have a price of house. If it is more than $10,000, don't buy. If it is less than $10,000, then we have to look for locality. For example, we can take a small reference by going to the now in terms of a small example for decision tree. Let's say we have price of the house. Just a moment. So here we can find price. So here we can have a decision box for price. If price suppose is greater than 10,000, 10K, $10K, suppose here, then the decision would be do not buy, don't buy the house. Will be don't buy the house. All right. And then if it is less than $10,000, then again we can have more branches defined. If it is less than 10,000, and here we can define again a logic. Suppose if the locality, now here we can define based on the locality itself. If the locality is good, then it should buy. Then again, we can say don't, if the locality is not good, then don't buy. If it is good, then again, we can focus on how many number of bedrooms are there. If the number of bedrooms, suppose, is less than one, then don't buy. If it is more than one, then we can define the parking space, how much parking space we have. If there's no parking space, don't buy. If there is, then we can check for facilities and so on. So basically here we are defining multiple decisions, right? Here we are defining multiple decisions here, and that's how it is going to be divided. Important now, we can note down here that decision trees are basically built on the entire data set by making use of all the variables that there is. And in simple words, after creating multiple decision trees using this method, each tree selects or votes the class. And for example, we have taken the house here, house example, right? And to conclude, the decision trees are built on the entire data set using all the variables, whereas random forests are used to create multiple decision trees, such that each decision tree is built only on a part of the data set defined. Now, we may have a question why to use random forest. So you might be wondering why use random forest when we can solve the same problems using decision trees as well. So even though decision trees are convenient and easily implemented, they lack accuracy, and decision trees work very effectively with the training data that was used to build them. But they are not flexible when it comes to classifying the new sample, which means that the accuracy during testing phase is very low. And this happens due to a process called as overfitting here. So overfitting occurs when a model studies the training data to such an extent that it negatively influences the performance of the model on new data. This means that a disturbance in the training data is recorded and learned as accepts and as the concepts by the model. So, but the problem here is that these concepts, they do not apply to testing data and negatively impact the model's ability to classify the new data set, hence reducing the accuracy of the testing data. And that's why random forest comes in. It is based on the idea of bagging, which is used to reduce the variation in the predictions by combining the results of multiple decision trees on different samples of the given data sets. All right. And that exactly is what ensemble learning is. Basically, here, random forest uses the ensemble learning method, in which the predictions are based on the combined results of multiple individual reports. So let's say here we have an elephant is like a big snake. Again, no, it's like a tree stump. No, it's what are you saying? It's like a sheath of leather. Again, you all are wrong. It's actually like a furry mouse. So again, these all are different. Again, the fables of blind men and an elephant, right? So again, these all are different inputs that we take in as in part of combining the results and combining these different parameters and get the results. So here we have something called as bootstrapping bagging. So basically that we also refer as bootstrap. So basically bootstrapping is an estimation method that we use to make predictions on a data set by resampling it. And to create a bootstrap data set, we must randomly select samples from the original data set. So a point to note here is that we can select the same samples more than once as well. So let's say here we have bootstrap data set, chest pain, yes, blood circulation, yes, blood arteries, yes. Weight 169, not sure how they are living. And heart disease is definitely a yes. And the word count, again, yes is going to be 95 and no is going to be 5 itself as a part of bootstrapping model. So what we do here is we create multiple decision trees by bootstrap data set created in this given data set here. So since we are making a random forest, we will not consider the entire data that we have created. Instead, we will use only random subset of variables at each step. And here we have boosting. So boosting is basically training a bunch of individual models in a sequential way. So each individual model items learn from mistakes made by the previous models. And that's how they simply work on improvising the accuracy one by one. So for example, here we have taken the example. Let's say we selected blood flow and blood arteries. Now, out of these two variables, we must now select the variable that best separates the sample. For the sake of this example, let's say we have blood arteries is most significant, we can say predictor, and thus assign it as a root node. And the next step should be to repeat the same process for each of the upcoming branch nodes. And hence, we can again say that two variables are random as candidates can be selected for the branch node, and then we can choose a variable that best separates the samples as well. All right. And then we have here we have random forest and a log heap. So basically, Chandler, let's say Chandler is planning for a 1-year vacation trip. So in order to decide which place should he travel to, he asks his friend for the advice. And they give again some advice. He got different advices over here. From one friend he got the trip suggestions in terms of the trekking, and the other friend gave again for the hiking itself again, and we got multiple other suggestions, right? So every friend gave suggestions by asking him few questions. And now it's upon Chandler to make a decision. So later on, Chandler asked one more of his friends to advise him. Once again, his friend asked him different questions to recommend about the places. Now, after talking to all of his friends, he decided to visit the place with the most number of votes. And this above scenario is a typical example of random forest algorithm. So here we can create a complete random forest itself by combining multiple decision trees. So as we discussed, first of all, we have to create a decision tree by using the Bootstrap dataset that we had defined. So now, since we are making a random forest, we will not consider the entire dataset that we created, and we can focus on just few of them. For example, here we have the entire dataset. Then we are going to divide them into multiple subsets, and there we are going to divide the dataset into n different subset here. And then we have the decision tree. So here we have step 2 as a part of DT. Here we can have another decision tree defined. And then we can use a random forest subset of feature to split the tree here. And then we are going to make use of each individual tree for creating a prediction. And then we are going to collect the vote of results from all decision trees available here. And then we are going to get the final prediction where we are going to find the maximum number of votes as well. So that's why these steps are required here. First of all, we have to create the Bootstrap data set by, again, which is basically a resampling technique as we discussed to estimate the population by sampling a data set with a replacement. That can be used to estimate summary statistics such as a mean or standard deviation. And the Bootstrap data set is created by randomly selecting samples from the original data set. So for example, here we have family history, high BP, overweight, the total weight, and the possibility of having diabetes as yes or no. Which simply involves the bootstrapping itself, which is basically an estimation method which is used to make prediction on our data by resampling it as well. And then, for example, this is our original data set as family history no. So here we are simply going to make random selection and then creating a bootstrap data set with randomly selected samples on the original data set here. And third and fourth randomly selected sample in bootstrap data set are the same as you can see here. So now we are going to create a decision tree as a bootstrap data set. So we are going to create a decision tree, example root node and the blood circulation using the bootstrap data set. And instead of considering all 4 variables to figure out how to split the root node, in this example, we can consider only 2 variables at each step, like we have blood circulation and blocked arteries. And now we need to figure out how to split samples at this node. So the decision tree is going to be based on the random subset of variables at each step. And first of all, we have to get back to step 1 and repeat. So where we have to build new bootstrap dataset and rebuild decision trees, considering a subset of variables at each step. So ideally, we have to repeat this step hundreds of times as we create multiple decision trees out of it. And then using a bootstrap sample and considering only a subset of variables at each step results in wide variety of trees. And this variety is what makes random forest more effective than individual decision trees here. And in terms of how to use Bootstrap and how to use random forest, so in this case, as you can see here, we have this Bootstrap data set. So we are going to predict if the patient has diabetes or not. And again, if it is yes, then again, in this case, yes receives most of the votes and patient has the heart disease. So let's say we created 100 decision trees and this is the overall count of the predictions from all the decision trees. Next thing is to find out the option which receives the most votes. And that is what we define as a part of Bootstrap component. And then in terms of understanding how good our model is, we can remember this entry as a part of 1/3 of the original data set, which was not included in the Bootstrap data set because of duplicate entries. And this is the entry that did not end up in the Bootstrap data set, and this is known as out of the bag data set. All right. And then, since out of bag data set was not used to create this tree, we can run it through and check if it correctly classifies the sample as no in the given database. Again, the family phase tree, again, true or false, and then it is going to give us the prediction. If again it has been yes, and we can run this out of bag sample through dataset or all the trees that were built without it, and we can use the prediction as no, no. Like if the votes are more for no, then means we have to label with this with the most votes wins and assign and write. In this case, random forest has correctly labeled the out of bag sample here as a part of no prediction here. And next is what we can do here is we can simply do the same thing for all the other data set one by one, and then we can, and that's how we simply generate the best results out of it. So that's how we can define the entire samples here. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.